report. There we go. Any questions about the second page of notes with some maybe slightly trickier problems there? I'm gonna hopefully get y'all to be a little less shy today, because we're gonna break out into some groups here for about 15 minutes and then come back together and solve the problems that we're going to solve together for class today. All right, so any questions about those? No questions. All right, so if you can hop on to Google Classroom, you might have already printed this off. On Google Classroom, there's a document that's called Verifying Identities Extra Practice. So where it says extra practice for class Thursday, April 23rd. If you could open up that document, and I'm gonna spit you into a group. It looks like we've got enough people for 2 groups of 3 here. It looks like what we've got. So I want you to go through and talk to your group about which of these problems would be easiest to solve, and try to solve those, and then we'll come back to a big group and we'll go through those 8 problems together, and then that'll be some good practice for getting you ready for this week's assignment. So go into 2 different rooms. It's going to give you a little text box that says, hey, you've been invited to this room. Would you like to join this room? Just hit yes, I accept, I will join. All right, so 15 minutes, try those 8 problems, solve the easiest ones first. I'm gonna poke my head into each room and help you guys out and see if y'all have any problems, okay? So just be sure you click join whenever it pops up as a text box here in a second.
It, on average, decreases your credit score by 5 to 10 points.
No.
If you have a strong credit history and no other credit issues, you may find that your score drops less than that. The drop is temporary.
Oh, that's good. Hey, welcome back, guys. Welcome back. I wonder if I can go in the other room and tell them we're coming back together. I don't think I can. Do y'all are y'all talking to Lauren? Is Lauren doing okay? She wasn't able to make it today?
Her laptop's having problems.
Oh man, that's not good. I'll reach out to her and see if she needs some help. They've been like handing out other laptops at school and stuff.
Mm-hmm.
Tell her I'm sorry that's happening. That's not very much fun. Hey, there's Sam. Okay. There's Joanne. There's Omar. All right. Okay, so let's look at number 1 first. And now that y'all are have your vocal cords warmed up, talking to each other, maybe we can share out a little bit more. So Omar and Sam and Jawan told us that they were going to talk us through some of what they did on number 1. Actually, before they tell us that, Tess, you had a good idea for what to do first on number 1. What was your idea?
To go ahead and take the tangent to sine over cosine,
Right.
and the cotangent to cosine over sine.
Right. So what's really nice about that is we can go ahead and bam, cancel that, bam, cancel that, right? So now we've got cosine of x times sine of x over cosine of x plus cosine of x, and we're going to see what that equals. Okay, so Omar and Yuan and Sam, what did you guys do next on number 1?
You FOIL the cosine.
Yeah, like multiply that through. Okay, so what happens with the first term? What do you get with the first term?
It cancels.
Right, so that's just sine of x. Cosine of x times cosine of x is cosine squared x, and that's what we were trying to get, so we're done with that one, right? That's good news. All right, cool beans. So we're just gonna go through the rest of these, and the more y'all can help out with them, the quicker it'll go, and we'll be free after that. So for number 2, we're going to work through the left-hand side. So this means cosine of x minus sine of x times cosine of x minus sine of x. So how should we simplify that expression? That's a binomial times a binomial. How do we work that out?
Just FOIL.
FOIL, that's right, that's right. So cosine of x times cosine of x is cosine squared x. First, outside. So we're going to do the sine of x first times the cosine of x. First, outside, inside. So now we're going to put minus sine of x times cosine of x last. Negative times the negative is a positive, so that's plus sine squared x. Okay, now there's 2 terms that we want to put next to each other. Which 2 terms should we group together?
Sine squared and sine squared.
Right, because that's our Pythagorean identity that we worked out first thing today. And since we have 2 sine of x times cosine of x terms, we can put minus 2 sine of x times cosine of x. All right, this equals what?
1.
That's 1. And whammo blammo, we've got exactly what we were trying to get. There we go. Okay, so when I'm working through problems with my AP students, the tip that I'm always going to give them is to solve the easiest ones first. So I was talking about this with Sam and Omar and Jawan. Number 4 is the hardest one. So we're going to do number 4, the very last thing. Okay, so out of 3, 5, 6, 7, and 8, which one looks easiest? Which one do we want to do next?
3.
3, okay, 3. All right, I'm going to flip to another piece of paper here. And my next question is, which side of the equation do we want to manipulate? Do we want to move stuff around on the left-hand side or the right-hand side?
Left.
There's not a whole heck of a lot to move around on the right-hand side, right? So we're going to write out 1 minus cosine of x times 1 plus cosine of x over cosine squared x, and we're going to see what that equals. Okay, so there's pretty much nothing to do in the denominator. We need to FOIL again. Our FOIL powers have already been warmed up. So first is 1, outside is plus cosine of x, inside is minus cosine of x, negative cosine of x times positive cosine of x, that's minus cosine squared x. That's all over cosine squared x. All right, so good news, those cancel out. And we've got 1 minus cosine squared of x over cosine squared of x. Now, oh, it's blurry, sorry, whoops. Now, the good news is this equals something that's going to move the problem forward pretty quickly. What, if you think about the Pythagorean identity, what would 1 minus cosine squared x equal?
Sine.
Sine squared x, right? So let's prove that real quick. Cosine squared x plus sine squared x equals 1. If we move that cosine squared x over, then we get sine squared x equals 1 minus cosine squared x. So we can do that substitution now. This numerator is really sine squared x over cosine squared x. Now, I think you're going to understand better what's really going on here if we like take a couple intermediate steps to show why this equals tangent squared x. So sine squared x is really sine of x times sine of x. Cosine squared x is really cosine of x times cosine of x. Well, this is just doing what Tess told us to do before backwards. Tess said that the tangent of x is the sine of x over cosine of x. Well, if that's true, then the sine of x over cosine of x has to be tangent of x, but we've got 2 of those multiplied together, and that's how we get tangent squared x. All right, we're mowing these down. We can't do number 4 yet, though, so which one should we do next? Which one is easiest? Were the ones with fractions easier or harder? There's no right or wrong answer to that question. Y'all are too shy again.
I also think the ones with fractions are a little bit harder.
Okay, so let's say 5 and 8 to the end. So let's do number 6 now. Number 6. All right, so which side of the equation should we manipulate? The left-hand side or the right-hand side? Right-hand side, yeah, I agree. So because there's that cosine of x that we can distribute through there. So nice simple distributive property to start off with. Sine squared x times cosine of x minus sine to the 4th x times cosine of x. Now, what is the greatest common factor that we can factor out of both of these terms?
Cosine of x. Or sine.
Yeah, we can do both, right? We
Squared
can factor out a
x.
sine, good Sam, sine squared x, and then also a cosine of x. So what's left, oh, blurry, sorry. What's left inside the parentheses after we factor out that greatest common factor?
Squared.
We've got a sine squared here, that's right. There's nothing left from this term, so what do we put?
Negative. Right.
There's a negative, yep, that's right.
1.
1, right. So this is actually like really good practice for when you get to calculus next year in pre-calc. Calculus is not that hard. It's just the factoring in calculus that's hard. So this is good. This is good factoring. It's good practice. Okay. So what does 1 minus sine squared of x equal?
Squared.
Cosine squared x, right? That's the Pythagorean identity. That's the same thing that we did on one of these pieces of paper that I have. Too many papers. That's the same thing that we did here, except we would be, like, imagine subtracting sine squared of x on both sides, and it would be cosine squared x equals 1 minus sine squared x, right? So we're going to do that substitution here. We've got a sine squared x times cosine of x left over. All right, and so now if we multiply cosine of x times cosine squared x, that gives us the cosine cubed x that we're trying to get on the left-hand side. Bam. All right, and we said no fractions yet, so we're going to do number 7 next. You guys have answered my which side of the equation do we work through first question right every time. There's nothing to really mess with on the left-hand side, so we're going to do 1 plus tangent squared x times secant squared x.
I think we should write everything in terms of sine and cosine.
What a great idea, Joan. That's a fantastic idea. Okay. So this is going to be sine squared x over cosine squared x. So since we went through and did the, like, oh yeah, this is sine of x times sine of x. Oh yeah, that's really sine squared x. We're kind of skipping a step there, but that's nothing too difficult. All right, that's 1 over cosine squared x. Cool. All right, what now?
Foil.
Foil, okay, yeah. Distribute. So this is, and I'm going to try to write this pretty carefully to where I have some room out here on the left. This is 1 over cosine squared x plus, what is this term going to be? A big blurry mess. Okay, now it's a, hey, that's great. Now it's a less blurry mess. So what? It's 1 over cosine squared of x plus, well, 1 times sine squared of x is still sine squared of x. And this is cosine of x to what power?
Cubed.
So if this were just cosine x, it would be cubed. That's cosine squared times cosine squared. We want to add those exponents since we're multiplying like basis. That's going to be cosine to the 4th. And I don't really need to put that in parentheses anymore. There's no harm in doing that, but that'll just give us more room. Okay, we've got 2 fractions that we're trying to add together. So what do we need to get?
And denominator.
Common denominator. What would be a good common denominator to shoot for?
cosine to the fourth x.
That's right. So we need to multiply the numerator and denominator here by cosine squared of x. Cosine squared of x. All right. So this is shaping up pretty nicely because we've got the same denominator. This is cosine squared x. This is sine squared x. And when we combine those into a single fraction, what does the numerator really equal? Cosine squared x plus sine squared x is Pythagorean identities. Oh my gosh, it's in the chat. Somebody's answering in the chat. This is exciting. It equals 1. Very, very good. So now that we've got 1 over cosine to the fourth x, if we do the reciprocal of cosine, that gives us secant. But since it's cosine to the fourth, that's going to be secant to the fourth x. And I believe that's what we were trying to get. Yep. Bam. All right, so now we've got these problems that are just a little trickier because they've got fractions that we have to work out. So 5 is like just a couple steps less than number 8. So let's look at number 5 now. We've just got to do 5 and then 8 and then 4 and then we'll be done. Okie dokie, number 5. So we're going to work out the right-hand side of that expression. And there's a kind of a trick that you're going to use a lot in calculus. If we could get this to say 1 minus cosine squared x, then we could do a substitution. Then we could get this to say sine squared x. And so you say, all right, so I want this to be 1 minus cosine squared x. So I need to multiply by 1, and I need to multiply by cosine of x. But what sign do I want to put right here to get a negative cosine squared x? Well, if I put a plus sign right there, that would be cosine x times cosine x. That would be good. 1 times 1 would be 1. But I would get cosine x plus cosine x, and that would give me 2 cosine x. So we want to make that a minus sign. It's kind of like the difference of 2 squares. Remember whenever we did, and you did this all the way back in Algebra 1, a plus b times a minus b equals a squared minus b squared. Well, it's gonna come out to be the same thing here. If we multiply the denominator by that, we better multiply the numerator by the same thing. All right, so now it's in the numerator, sine of x minus sine of x times cosine of x. All right, and just as a little aside, let's do that FOIL real quick just to make sure that it works. FOIL, we're getting lots of good binomial practice today. Inside last minus cosine squared x. Hey, those cancel out. That's good. So this really is 1 minus cosine squared x. So how do you know to do that? Well, that's just kind of a trick that you pick up on whenever you do enough of these. You start to see, like, if I don't have any other thing that I can do, but I have a binomial in the denominator, maybe, just maybe, if I can you call this the conjugate. We did complex conjugates earlier where it was like the same real and imaginary part, but one was positive and one was negative. So you want to do that here so that you can get that sine squared x in the denominator. All right, so that's kind of nifty. And in the top, what we can do is we can do another greatest common factor. We can factor out sine of x. That's 1 minus cosine of x. All right, so what is this problem telling us that we want on the left-hand side? We want 1 minus cosine of x equals sine of x. Well, hey, that's really, really good news because I've got my 1 minus cosine of x here. This is sine of x. This is sine of x times sine of x, so I can cancel out this sine of x with one of the sine of x quantities in the denominator, and bam, that gives us what we want on the left-hand side.
I have a question.
Yes, just one.
X to get 1 minus cosine squared of x, wouldn't you have to multiply it on the left-hand side also of the equation?
Well, all you're doing is you're saying cosine squared x plus sine squared x. Oh, are you saying this
Yes.
for the first step? The reason you don't have to is because that's just multiplying by 1, right? So let's say I multiplied, whenever your algebra teacher always says, like, you got to do the same thing on one side of the equation that you do to the other. That's if you're changing the value of one side of the equation. So if I multiplied this side of the equation by 2, I would need to multiply the left side of the equation by 2 also, right? But since we're multiplying by a clever form of 1, that's not changing the value of the right-hand side of the equation. So it's still equal to the same exact thing on the left-hand side.
It's basically the reverse of simplifying, right?
Exactly. Yeah, that's exactly right. Yeah, that's a good question. So we're going to do the same type of thing on number 8. So since you guys were always saying let's always do everything where we change it in terms of sine and cosine first, that's going to be what we do in this problem. So what does secant of x equal? Secant is the reciprocal of sine or cosine or tangent.
Cosine.
Cosine, right? So this is really 1 over cosine of x plus 1 over 1 over cosine of x minus 1. Now, in order, so this is going to be, it starts out looking really similar to number 5, but instead of being a do the conjugate problem, it's going to be more like one of the problems from the first part of the notes, like compound fractions, a fraction over a fraction. So we're going to first get a common denominator in the top fraction. We've got cosine x in the bottom here, so we want this to be times cosine of x over cosine of x. Same thing down here, cosine of x over cosine of x. So this is 1 over cosine of x plus cosine of x over cosine of x. That's all over the same thing. But we've got a minus sign right here, right? Okay, so we can simplify those into a single fraction up top over a single fraction in the denominator. So now we're going to, and I'm out of room going down, so I'm going to bring it up here. How do you simplify a fraction divided by another fraction? Well, dividing fractions is really easy, right? You keep the first fraction the same, you change it to multiplication, but you flip the fraction on the bottom, right? You multiply by the reciprocal of the denominator. So that cosine of x is going to go up top. That 1 minus cosine of x is going to go in the bottom. And I think that pretty much gives us exactly what we want, yeah, because those cosine of x cancel out. In the numerator, we're left with 1 plus cosine of x, and in the denominator, we're left with 1 minus the cosine of x. Cool beans, cool beans. So we've only got one problem left, the big scary one that we saved for the end, and that's number 4. So the reason number 4 is a little bit trickier is because we've got to actually work out both sides of the equal sign. So I'm going to start this on a brand spanking fresh new sheet of paper. So I'm going to write out both sides. Tangent of x plus secant of x equals cosine of x over 1 minus sine of x. So the trick that we're going to use on the right-hand side is going to be to multiply by the conjugate. We want this to work out to be 1 minus sine squared of x. So we're going to put a 1 first. We're going to put a sine of x here. But since this is starting out as 1 minus the sine of x, we want to put the opposite sign. We want that to be 1 plus the sine of x. So we're just multiplying by a clever form of 1. We want this to be 1 plus the sine of x over here also. So let's FOIL out the top. So this is the exact same foiling that we did before. 1 times 1 is 1. Negative sine of x times sine of x is minus sine squared x. That inside product is going to cancel out with the outside product because that's negative and that's positive. So 1 minus sine squared x, that gives us cosine squared x. We can factor out a cosine of x from both of these terms. So that's 1 plus sine of x. We already saw this either the last problem or a couple problems ago when we had sine of x over sine squared x. Well, this one cosine x can cancel out with one of the cosine x's in the denominator. So we've got 1 plus sine of x over sine of x. So sometimes when you look at these problems, it's not totally clear which side is simpler than the other. Like there's stuff that we can simplify on both sides of this, right? So if that's the case, there's not really much more that we can do here. That's not the same thing that we have on the left side, so we have to work this side out also, okay? But Tess was telling us from the beginning, hey, tangent of x is sine of x over cosine of x. Reciprocal identity, that's some of the easiest ones that we have. Secant of x is really 1 over cosine of x. Well, hey, this one is way easier than we thought, maybe, right? Because cosine of x is our common denominator. Sine x plus 1. Well, the commutative property tells us it doesn't matter what order you add stuff in. Sine of x plus 1 is the same as 1 plus the sine of x. And so that gives us exactly what we need. Cool. Any questions about that one or any of the other ones? So for being here today, you get kind of a helpful point in the right direction. Hold on just a second. I'm going to show you something on Google Classroom. The assignment this week is like a choose your own adventure assignment. So you don't have to do all of the problems that are on there. Share screen. There we go. So if yes, and it appears that I put in the thing, but I didn't add the quiz. So Omar, you were correct. I made the assignment, but I didn't post the quiz. So instead of making you guys watch me go through my email and post stuff, you don't have to do every single problem. There's different points values on the different problems, and you have to solve problems worth up to 10 points. So I'll send a remind message here in just a second once I've got that up, okay? Thank you guys. Appreciate y'all being here. Let me know if you have any questions, okay? Good to see you.